guess who's back? It's another math episode from Mr. Mac. Alright. So now we'll be working on task number 2, writing equivalent expressions. Let's factor, simplify, and rewrite the expressions with confidence. Example number 1. We want to write the following sum as a product of two factors in factored form. So when we look at this expression, in order for us to do that, we want to find what we refer to as our GCF, our greatest common factor. When we look at 9m, we look at negative 3p, and also the number 21. What's the greatest number we know that divides evenly into them without leaving a remainder? Alright, so what you can do is start listing out the factors of the bigger number, the biggest number that we have here. So for instance, this helps out some students. I'm going to write the number 21, that's our biggest number here, and then the factors that we have. 1 and 21, 3, and 7. Alright? 21 is not a factor of all those numbers. 7 is not a factor of all those numbers, but 3 is. So that's going to be what we refer to as our GCF. That's the greatest number that evenly divides into all three of these. So I pull that number 3 out, referred to as my GCF. And now that I have that GCF, I'm going to divide each of these three terms by that GCF in order to see what am I going to multiply that factor 3 by, aka that number that divides evenly into this expression. 9m divided by 3 gives us 3m. Negative 3p divided by 3 gives us negative p. And positive 21 divided by 3 gives us a positive 7. And that's it for letter A. Now on to letter B with 5x plus 10y minus 15. If I look at that number 15 and I think about the factors of the number 15, we have the numbers 1 and 15, 3 and 5. I believe that's it. So 15 is not a number that divides evenly into all three of these numbers, but 5 is. That will be our GCF. So we pull the GCF out, which is the number 5, and we take that factor of 5 and divide it into all three terms into our expression. Alright, 5x divided by 5 gives us x. Positive 10y divided by 5 gives us a positive 2y. And negative 15 divided by 5 gives us a negative 3. And there we go, and it's in factored form. For question number 2, we want to write the following expression as a sum of unlike terms, aka in standard form. In standard form because we want to simplify them. So let's go ahead and simplify it by first step 1, combining the like terms. Alright, in this case, we have 12y, and another term that also has a y attached to it is 3y. So when I do 12y minus 3y, that gives us 9y. Now let's take a look at the second part of the question. We also have positive 8, which is a constant, and a negative 5. 8 minus 5 gives us a difference of positive 3. So our final answer should be 9y plus 3. Let's go ahead and use a similar technique on task number 2, question 2b. We have our 9a. And when I identify its like term, always look at the sign in front. In this case, there is a minus 13a. So when I interpret that, I interpret it as 9a minus 13a. Now with my other set of like terms, I have a constant of negative 6 and a constant of positive 2. I'm looking for my like terms, and I like pairing them together. You don't have to do that step, but for me personally, when I pair them together, and in this case I actually color code them, it just helps me to utilize these terms a little bit easier. So 9 minus 13, if you're having a hard time doing that, you have your calculator, or think to yourself, what's 13 minus 9? 13 minus 9 is 4, but if I'm asking you the opposite question, I'm expecting the opposite outcome. So there goes a negative 4a. You bring down your letter, and when you type this into the calculator, please do not try to type in the variables. That may mess you up. For the second portion, negative 6 plus 2, that gives us a sum of negative 4. Now on to letter C. Similar question, except we have parentheses around both. So let's go ahead and simplify it. I recommend utilizing the distributive property. I personally like to put the number 1 in front of all my parentheses if there are no number in front of my parentheses, and I interpret the first one as a positive 1. And what I like about multiplying a value by a positive 1 is that you get the same exact outcome. So those are normally fun for me. I get 4y minus 1, and now on the other end, it's no longer a positive 1 because there's a symbol in front of that, so our minus symbol. I look at it as negative 1 times 2y, which is negative 2y, and negative 1 times negative 3, and negative times negative gives us a positive, so that's positive 3. And now I can go ahead and combine my like terms. I have a positive 4y, and I also have a negative 2y over here. Please pardon my handwriting. I'm going to try to fix that y up for us because that's a little oobla. So there goes our negative 2y. And when I rewrite it as 4y minus 2y. As for the other portion, we have a negative 1 plus 3. And I'm going to rewrite that together. Negative 1 plus 3. Continue to my red. 4y minus 2y. You subtract the coefficients and you keep the variable. So in your calculator, you are only doing 4 minus 2. That gives you a difference of 2. And you keep the variable y. Negative 1 plus 3. Pretend you're on the negative first floor. You go up 3. You should be at the positive second, or the second floor above the ground. On to letter D. The thing I love about letter D is that we're subtracting. They both have the variable x, so they are like terms, and they have the same exact denominators. This is awesome. One thing you can do is think about when you're subtracting fractions, you need to have the same denominator before you go ahead and do so. So we got the green light. 19 minus 5 gives us 14. You keep the variable, you keep the denominator of 2, keep your x attached, and when I simplify that, I get 7x. On to letter E. We're going to find the sum of both of these values. Again, when I find the sum, I want to try it a little bit different this time. This time I want to stack them up vertically. So I'm going to start by writing my first term, 7x plus 2y minus 3. And underneath, I'm going to stack my second term. And I have to make sure I write that y to look more like a y, because what I'm realizing is it's always looking like an x. My second term is going to be 5y. Notice the first term in here has an x, so I'm going to place the 5y directly underneath the term that has a y. And my second term is minus 6. Since I'm adding, I can go ahead and add. Negative 3 plus negative 6 gives me a negative 9. Positive 5y plus positive 2y gives me a positive 7y. And 7x has no like term, so I just bring down the 7x. So as we continue with task number 2, we're going to be using the properties of operations to write an equivalent expression as a sum of unlike terms, aka in standard form. So the first thing I'm going to do is just rewrite the expression, and I realize the number 8 is in front. Personally, whenever I see a number is not in front of my parentheses, I like to place the number 1 there as my placeholder and then apply the distributive property to get rid of my parentheses. One misconception I want to highlight is over here. When we do the positive 1 times the negative 5r, a lot of people just always bring down that plus sign and then they do the 1 times negative 5 and get the minus 5. Refrain from just bringing down the symbol and think about it as multiplying two integers. The integer of positive 1 times the integer of negative 5, and it gives you a product of negative 5r to avoid having two signs next to each other. Again, the idea of this is to simplify it, so never just make it a habit to just bring down the sign. Multiply it if there's two integers. If there's a sign in front, you make sure you multiply it to get that one symbol. Now let's combine like terms. 32r minus 5r gives us 27r, and negative 8 plus 5 gives us negative 3. We're going to go ahead and apply the distributive property to the next question as well. That kind of distribution I have so much confidence in you all being able to do. Now it's time to combine our like terms. I have my negative 6x since there's a sign in front, and I have my positive 50x. Those are my like terms, and that gives me a sum of 44x. And lastly, I have a positive 3, and it's subtracting 60, and that gives us a negative 57. Now on to question letter C. Some people are naturally intimidated by a question like this because we have a minus sign in front of both set of parentheses, but don't. You have your and it's there to provide you backup. In this case, we have negative 14x minus 3x. That gives us negative 17x. And last, we have negative 35 plus 3, and that gives us a negative 32. Now on to the next question. Notice there's only one set of parentheses, so there would be one piece of distribution that we apply. I recommend when you do your distribution, distribute the negative 3. So you think about it as negative 3 times 2m, which gives you the negative 6m. A lot of people make the careless mistake and they automatically try to do 9m minus 3. In this case, they're not like terms. But let's say I even gave you a 9 here. If a 9 was there, you still will start off with the distributive property. So I wanted to point that out before I go any further. You will not get 6. You start with the distributive, and you're distributing the number negative 3 to both the terms to get rid of your parentheses, and then you combine like terms. So it kind of goes like this. Negative 3 times 2m gives us negative 6m. Negative 3 times positive 1 gives us a negative 3. And then you bring down your 9m. Now you see a set of like terms. That gives us 3m minus 3. On to the next question. Again, in question letter E, I do not see a number in front of my set of parentheses, so I put the 1 there, and now we start doing your distributive property. Once you've distributed, you combine your like terms. The ones with the r gives us 14r. The ones without gives us plus 31. On to the next question. I see there's a set of parentheses here. Start with my distributive property. And as we go further, I'm not going to explain every single step because I'm expecting you to get better at your own multiplication, and you can check it over with your calculator to see if I'm making any careless mistakes. Now that you've applied your distributive property, you bring down your plus 8 and you combine your like terms. And in this case, 6 plus 8 gives us 14, so our final answer is 14x plus 14. Next question, same concept, but we're just utilizing the distributive property with numbers that are decimals. Let's go ahead and do it. Now, once we've distributed the constants, we can then go ahead and combine our like terms. And always remember that when we do that, we want to just make sure that we combine the ones that have the same variable to the same degree. In this case, we get that. And over here, we have a negative 12 plus 18, and that gives us a positive 6. Now on to our last question. This time, instead of distributing the constants, we're distributing the fraction. Let's go ahead. 2/3 times 12x, 2/3 times negative 18y. Now, something that can be tricky about this question once you've applied your distribution is realizing that you're not done. This term has an x attached to it. This term also has an x attached to it. When I combine them, I get 12x. And I simply bring down my minus 12y. And that's it.